Okay, we are back, and I have the dog trapped with me tonight. That's right, buddy. You're not going anywhere. No, you're sealed in here. He's already looking for an exit. Just calm down. Just calm down. Come on, you want to make an appearance? Come on, come on, come up here, come up here, come on. Just say hi to everybody. Come on. Merle, get up here. Come on. Come on, they need to know that you're real. Come here. Come here. There you go. Oh, don't step on the keyboard, though. Okay, there we go. All right. So what are we going to talk about today? We're actually going to continue on... Come on, show the cute face. Oh, there you go. Yeah, you good boys. We're going to continue on avoiding racing to the end. I actually want to dig in a little bit deeper on the problem we were looking at last night. And along those lines, we're going to assemble some other points that I kind of stumbled into last time, which is some of these are almost like a combination of multiple things. So, yeah, just for a little bit, you get to hang out with me. So, in addition to avoiding racing to the end, other characteristics that I think are relevant to this one. Really, buddy? Where are you going to go? He just doesn't like the adult voice. Yeah, I know, but I can't talk in the doggy voice to the GTT crowd, okay? I gotta talk in the professional voice. Anyway, he's giving me the guilt look now. It's off camera, but it's hilarious. Okay, so we're going to think deeply on complex problems and iterate. So that last problem we were looking at, I would argue that that is complex. And we're going to iterate on it because there's more stuff to do. And we are going to try to avoid getting distracted by the little things. I don't know if Merle's adorable face is a little thing or a big thing, but it's distracting me a little bit right now. And then, that doesn't apply, foster goodwill, I don't know if that applies. Don't focus solely on the material. This actually does apply. And it applies because, well, I have many thoughts on this, but I think it's Jeff Bezos that talks about how there's sort of two types of founders. There are missionaries and there's mercenaries. The missionaries are the people who dedicate their life to a cause, and they do it because they want to kind of like make the world a better place. And they'll pour their whole life into the thing, and it will be a slow uphill battle the whole time. The mercenaries are the people that are going to get involved because something is going to make them money. They see an opportunity. It's the gold rush. It's the oil rush. It's the AI rush. And you get people that... I'm going to refrain from saying people's names. I'm trying my best. But you get certain people, and we all know who these people are, that are going to create companies to do AI, and they don't know anything about AI. And they're going to try to convince us that their snake oil is the right way to go, and it's not. And they're going to be a flash in the pan. Because people are gullible, but people are not stupid. And so they're going to fall for it momentarily, but then they're going to realize that you're selling them some snake oil, and then you're going to be found out. So you can apply that to whomever you want to apply that to, as long as they fit the criteria. Okay, buddy, you gotta go over there just a little. Okay, yeah, stay right there. But on this channel, we don't focus solely on the material, and in particular, we focus almost solely on the technical, well, and growth and stuff. And this is an example of not focusing on the material, because we're gonna go back and discuss ranges a little bit more, because frankly, I think they need some more attention, because I don't think we got it quite right, and there's more stuff I want to show. I actually wrote some of it down on this thing, on my little Remarkable here. Thanks, Taylor. Good call. Remarkable 2. Big improvement over Remarkable 1. Building a strong network, yeah, that could apply, given that hopefully the people that are interested in this, like I am, on starting at midnight 30, Saturday night, Sunday morning, those are my kind of people. So yeah. Inner circle wisely, yeah. Small footsteps, this definitely applies, because today's a long day. Last night, I think I was up until about 8 a.m. because I had to do some editing, and the voice wasn't quite right, and Raphael was a little too loud coming in on the speaker. I think it's better now. I have him through another channel. But so I had to do all these enhancements. Anyway, trying to stay true to my own virtues or characteristics, whatever, these habits. I don't know. We can work together to figure out a name for these things, but small footsteps every day. I think one of the best pieces of advice I've heard about conquering mountains is if you go to climb Mount Everest, the way to the top is not by staring at the mountain, not by staring at the sky, but instead by staring at your feet. And I think that that's brilliant advice. And the reason for the feet is if you stare up at the mountain, you stare at the sky, it can feel like you're not making any forward progress. You're not going anywhere. But if you look at your feet, every footstep, you can tell that you're making forward progress. You can see that it's happening. And that gives you the indication that you are moving forward. And so even in this case, we are moving forward one footstep at a time. And that's really important. And I really do swear by this one. And as I was mentioning to T, my goal is to try to do a podcast now that we have the stuff in place to finally launch the channel, which is something I've been dreaming up about doing for the last 3 years, but just things were not in place to do it. But now that I think things are in place, my goal is to try to do at least one podcast every day. Well, when I'm not traveling. If I'm traveling for various different things, conferences, customer stuff, board meetings, then I may miss those. But if I'm in NorCal, I'll try my best to try to do at least one every day, even on days when I'm super tired like today. This also falls in line with meaningfulness. I'm not doing this for happiness. And in fact, I think this idea of like the pursuit of happiness, I think it's pretty misguided. Because happiness, so the core of it is happiness is an emotion. And like, I don't know, there's this movie, it's a Pixar movie, it's like these people, or emotions or people or something, I forget the name of it. I actually haven't seen it, but I speculate that what they are trying to show is that the emotions have balance between themselves. Happy needs sadness, anger needs sorrow or something. They have a symmetric opposite. And I think that that's probably true. And that's why you don't aim for happiness, because in order for you to feel happiness, you have to feel sadness. So if you're in the eternal pursuit of happiness, that's just not possible. Because how can you be eternally happy if all you feel is happiness? Because eventually your happiness, if you feel that all the time and you feel no sadness, that happiness will turn into complacency. And you'll just be comfortably numb, as the Pink Floyd song, I think, kind of nails down. Complacency, I think, is better. Maybe comfortably numb is like a good spot to be in. But anyway, this podcast tonight is along the same lines of the meaningfulness. Is it's gonna, I think, add more meaning to our quest of becoming better coders, better at software development, and do more machine programming stuff. And by the way, I think at some point we will start getting into some pretty advanced machine programming things. But in order to do really awesome machine programming, we first really need to understand the other three domains. In particular, we really need to understand programming languages and software engineering. Because if we don't understand those, then how could we build a machine programming system that has value? I don't think that we can. In fact, this is part of the reason why I have some issues with the code assistants. I think it's cool, but I don't know that it is helping us solve something that we couldn't already solve, because we have humans that can assist us. And yeah, it's more nuanced than that for sure. But again, I think AI can do things that humans can't do, like reason about millions of lines of code and find issues in dark spaces, and yeah, do a lot more than check our mail kind of thing, right? We can check our own mail, but figure out how to build a trajectory for interplanetary travel from Earth to Mars as the planets are rotating around the sun. That's something maybe AI can help us with, right? So we're going to aim for meaningfulness, and meaningfulness means that we're going to focus on stuff that will, I think, have value over the long run rather than just the short term. And it may not give us happiness, but it will give us purpose. And I think deep down, most of us actually really want purpose. I think happiness is very fleeting, and yeah, it's not sustainable. And I think that in our heart of hearts, I think many of us know that that's not actually what we want. And I could go on, but we'll keep moving. But we're going to get into more of the meaningfulness today. And then there's other things, but I'm just going to quickly iterate on some other ones that will hit just so this has relevance. And the reason why I wanted to talk about this is this last time I realized that, and I think I sort of have done this implicitly in the past, is I was talking about mastering the basics and how not racing to the end helps us master the basics, because rather than trying to be done, we give ourselves the opportunity to go slow. And then by going slow, we can master the basics. And so tonight, we're going to continue to go slow, but we're also going to focus on certain things. So as we do these podcasts, I may just hit on the ones that I think are relevant. And in this case, we're going to continue to avoid racing to the end. We'll think deeply on complex problems and iterate. That'll be a primary focus. We will seek out failure, in that I think that the solution we came up with last night, it was not bad for a first attempt. Like, it kind of worked, but I think all of you hopefully know how I feel about this, is that writing software that works we can do way better than that. We should have a much higher bar, that we want our software to be able to fly spaceships and be resilient to all kinds of things. And so in doing the podcast last night, I think that we did actually seek out failure. And after reflecting on it today, I think that there's ways to improve this. And so on and so forth. I think that will maybe summarize it for now. Yeah, maybe one more. We'll keep doing this. This one, it does say down here, I found it last time, right? Prefer weak claims to strong ones. But notice it does say prefer. It doesn't say that you can't make strong claims. And strong claims are kind of like absolute claims, like there's 5,280 feet in a mile. And so this is also a strong claim. And my list, so I'm allowed to use strong claims when I want to. And hopefully I'm doing them in the right places at the right times. And this one, I do mean never. Personally, for me, if I stop growing, if I stop learning, I don't know what the purpose of life is. This is sort of, as I jokingly say, at the university and at the company, that the day I stop learning and growing is the day that I've died. And I really hope that that's the case. There obviously are some other challenges that could kind of, create issues. Anyway, that's good enough for now on the things we're going to talk about. Now let's go to code. But before we go and modify our code, I was pointing out, I think last time, actually, let's see here. Yeah, I was pointing out last time that in DentOS, with one of these issues, this one, what I really didn't like, one of the things that kind of drew my attention in, is I didn't like how they didn't organize this the way that I think we think about these things, which is this notion of lower is less than x is less than upper, which we can't exactly capture in C++, but we can do lower is less than x and x is less than upper, which kind of feels similar to this. And I like that stream of thought. I like that it gets us into understanding that this is the middle point. This is constrained between these two things. It's almost like in my head I can see this, right? Or I guess in this case I could see this, and I could also see this. Okay, that's probably more mathematically precise, since we're trying to be precise. You know me and the ASCII art. I really like to have my ASCII art here. Okay. So I said I kind of like this type of thing, and this gets us closer to this. And just for consistency, we'll get these two. Okay. Now, what does this have to do with anything? Well, as I was looking at Mentor, I was in OpenSSL, which, by the way, OpenSSL is, we got to talk about OpenSSL. Hopefully somebody at some point is on the channel that works on OpenSSL, and we can start. My mouse is acting up. This is not a good sign. I have a secondary one. It's strange. I thought I charged this one. Okay, hold on. Let's see. I have this other one over here. Okay, this one seems to be working. Yeah, probably just a charging thing. Gotta have a backup for those Merlians. Yeah, you know. Yeah, just for clarity purposes, so we can all see this. Yeah, like for real. Okay. So we need to talk about OpenSSL, because this is not great, and hopefully if at some point someone is watching this channel that works on OpenSSL, and you can connect with me or T or some of us, and we can get you access, because yeah, this is not great. This feels like an XZ utils backdoor waiting to happen, and Merly can't be the only ones that noticing this. So reach out to us, please. We want to give you unlimited, unrestricted access to Mentor, and we can work through these things. I mean, like, I know some of these are test things, but like, this is one of the new features that Mentor has. I mean, guys, this is a single control expression. Each one, like, what? Like, guys, I mean, look, this one in particular, this 953.1, this one's pretty long, right? Okay, just keep an eye on this one. It ends right here. Right, let me do this again. Mentor's not making this up. This is in production code. Now, again, I realize some of these are tests, right? But tests are used to test the code, and if the tests are so complicated that they're not maintainable, do we know that the tests are right? Or how do we properly evolve the tests? Okay? Anyway, OpenSSL people, please reach out. We want to give you unrestricted access to Mentor so we can all make it better. That aside, there's one thing that I saw with OpenSSL that I wanted us to look at, because it was reinforcing what I was recommending for the versioning. And here it is. Okay, so this is what I was talking about. So good job, OpenSSL. I love it. Now, I think this isn't as good as our range solution. I think our range solution is better because it's more clear. And by the way, this is still insufficient, so I'm gonna trash on my own code here in just a second. We'll get to that. But before we do that, as I was mentioning, I really like this idea of following the consistent operators, putting this in the middle, and then creating this kind of system. And then also not conflating, not doing a mixture of these things, just because it's not that hard. I know there's two different things, but like exclusive or inclusive, but just pick one and then change the numbers to be either all exclusive or all inclusive. Don't switch between them. You're just adding unnecessary mental tax, and that's likely going to be technical debt and bugs that you're going to create for the team. So just don't do that. Like what they've done here with OpenSSL. I love this. So they've got this no SSL 3, TLS 1, no TLS 1.1, no TLS 1.2, blah, blah, blah. And every single one of these is the same. Now, again, our range check, I think, is better because you can still fat finger these, and why risk it, right? Just make this a function and then just call the function, and then you don't have to worry about potential mistakes. So, but that aside, this is better than the DentOS, at least in my opinion, because it's harder to reason about. I think it does a mixture of inclusion and exclusion, which is not good. And then there's just, yeah, like why even the spacing, right? Like Yeah. These kinds of careless mistakes, I think, are a real fast way to degrade quality, because I think they're sending a signal to the maintainers that it doesn't really matter, right? Just get kind of close enough and you're good. And for production quality code, for stuff that you really want to be showing your best foot forward, I feel like we can do better than that. So I really like that. I just stumbled across this because I was just looking at OpenSSL early tonight. As I do, I just use Mentor all the time to just look at stuff. And I encourage all of you to do the same. Just drop your favorite repos in here and just see what's what. That's, I think, a great way to learn, especially with Mentor actually making life pretty easy in terms of explaining things. Yeah, I wonder. Huh, that's funny. Okay, I actually didn't. I was just going to focus on this. Yeah, this is what I'm talking about. In range. Yeah, just do the in range. Okay, good job, Mentor. Yeah. So I like this. This is a good step in the right direction. I think this is slightly better. And now we're going to go back to our code and we're going to try to make that even better than what we had last night. Okay, so the things that I wrote down that I wanted to talk about are, I do not like, even though I had a little bit of a nightmare last night that I accidentally said -1 twice, and I was like, oh no, I got it wrong, and I was like, didn't I test the bounds? And then I literally was in a pool of my own sweat when I woke up thinking, ugh, I'm so embarrassed. And then I saw that, oh no, I did +1, and I was like, oh good, that I can sleep now. But then I thought about it some more, and yeah, I don't like this. And I'll explain why in a second. But as I was mentioning last night, doing the -1 and the +1, this creates complications, especially if we really do want these to be templatized. And this is also this whole point of not racing to the end, that if we're really trying to do ranges that are somewhat meaningful, and we want to support exclusion and inclusion, there's a better way. And the better way actually is to do this, but then do another thing. And so we're going to change that. So that's the first thing I didn't like. The second thing I didn't like is I don't like that this only supports full inclusion or full exclusion. So as I suspect all of us can probably tell, there's really these 4 things. Oh, okay. I'm going to be super pedantic here. Is that okay? Okay. Be super pedantic just because I need the spacing to be perfect so I can think more clearly. Okay. These are the 4 variants that we can have. We can have full inclusion, full exclusion, inclusion and exclusion, exclusion and inclusion. Right? It's just truth table type thing. And our system just supports full inclusiveness or full exclusiveness. And I don't like that either. We should support all 4, because, I mean, even though I just said they should really just pick one or the other, it feels like mathematically incomplete to do that. And, one of the things that I do in my free time or sometime is I review research papers. And one of the things we talk about is whether or not solutions are exhaustive. And if something is not exhaustive as a solution, or if it's clear that they haven't reasoned about something in an exhaustive way, it kind of decreases the validity or the trust that I think those of us in the research community have of a solution. And so the researcher in me is saying that that's not exhaustive, but this is. And so I realize I'm contradicting myself. I get that. Things are nuanced, right? So yeah. I'm just gonna. This is literally Goju OCD kicking in here. Yeah, I'm like major OCD. Okay, cool. Now we have the perfect mappings, I think, for these. Yeah, okay. So whether we implement these 4 right now, I don't know, but minimally I felt like we should be on the same page that if we want to have this be fully exhaustive, then we really want, if we want these to be fully exhaustive, we really want them to have all 4. We don't need to do that now, but I think the audience should be aware of it. Okay. Now, this whole -1 and +1 thing. Okay, this has got to go. The reason why this has to go is if we really want to make these templates, the problem with the -1 and +1 is it is requiring us to essentially implement the binary minus or binary subtraction or binary addition. And I don't like that. I think that that's too much overhead, especially if we want this to be templatized. And there's a better way that we can do this. So before we do that, I just want to test that we can build again. Okay. Oh, and I remembered a little bit of my macros for running stuff. Okay, so it's saying this is within the ranges where we were last night. And so I think that that's all good. And now let's just let's just try to break it and make this -1. This should break it. This should output 0. Okay, so let's just assume that we've got that sorted now. All right, so the quick fix, the quick and dirty fix to this is we are going to still rely on this. Okay. And I'm just going to test. So this is us doing inclusion. And so I'm going to fix the exclusive one. And so for the first inclusion one, 16 is the value. This should break now. In fact, let's just test it back to where it was, so you can see that it works. And then I'm going to remove this, and then the result should be false. Okay, that works. So it gives us the true, right? And remember, that's what this is right here. And then I'm going to remove this, and because that 16 is on the boundary, and let's make sure that all the other ones are not on the boundary. Let's change this to 35. Let's change this to 50. So 16 is the only one that's on the boundary. This should break the 16 because we just deleted those, that -1. So you should see a 0 here. Okay, we see a 0. Good. Now, that's doing exactly what we wanted it to do. And by the way, let's just move this up here, just so it's a little bit out of the way. And by the way, I think that this is actually a useful form of comments. I find, at least for me, I find that this is very helpful, is comments in the traditional form of comments, I think, like, weird, okay. Like this, I don't know if this is super helpful, but I'm getting some weird lag on my machine. Wonder why. Okay, well, I hope it's okay. But comments like this, I think, can be really helpful because they're giving you a picture of things that you should be thinking about. It's like they're giving you maybe the cases that you should be working toward. Okay, so now we go down to here and we know that this thing is broken. So we can say if it's within this exclusion range, or lower. Whoa. Yeah, it's a keyboard delay. I was seeing this earlier today. Lower is equal to value, or yeah, okay. Yeah, okay. Okay, so now what we're saying is that it can be in this piece here. This is one potential outcome, but this can be false if it's not within the exclusive range, or we can have lower be equal to value or value equal to upper. Okay, let's so this is the reason why I pause on this is there's this notion of doing constants on the left-hand side, but they're all constants in this case. But usually the way you'd write this is the value would be a non-const. And now if you accidentally do this, it's like going to give you a compiler error saying, yeah, you can't do that because this is const. And so that's a cool little safety trick that some of us use to then make sure we don't accidentally do assignment when we meant equality. Okay, cool. So now the idea is that if it's part of the exclusive range, then it's good. Or if that's false, lower can be equal to value. That's acceptable. Or upper can be equal to value. That's also acceptable. Now, in theory, basically what we just did is the same thing, except now we didn't use -1 or +1, which will become important in a second, at least in my head when I was thinking about this earlier. Now, what should happen here is we should run this and we should get true again, because 16 was on the border before, and it failed because we were just using exclusion, but now we added the inclusion parameter, so lower is equal to value. So this should work. I mean, in theory. Okay, it works. Excellent. I'm happy about this. All right. So now we have still used exclusivity to implement inclusivity, but we also added these equality operations. Okay, so how does this make this better? Well, a big reason why this is better is if we start to create classes that want to use this, now all we have to do is implement the less than operator and is equal to. Whereas before we were going to have to implement subtraction and addition, and it's maybe not super easy. So let's just do a toy example really, really quickly. And maybe we won't get through the whole thing, but we'll start. And this hopefully will start to make sense. I'm actually worried that my keyboard... Okay, I think we're okay. So we're going to do social security numbers to try to demonstrate why this range thing is actually valuable for types that are more than just native types, like integers or chars, strings, things like that. Okay, so social security numbers, and for those of you who aren't from the US, they take this format of XXX, YY, ZZZ. And all of these can be different numbers, and the dashes essentially are just dashes. And so it's a total of 8 digits, and there's probably a rhyme or reason for the 8 digits, but I have no idea what they are. Okay, so we're going to build a class that is, we'll call it just SSN, mostly because I'm lazy. And you will often want to spell things out, but I don't know, I'm a little conflicted on this. On one hand, using acronyms is not great. Oh, and by the way, minimally, if we're going to do this, we should say this. And I also have somewhat of disdain doing this. Ugh, it's just like, imagine if it was this all the time instead of like, this. So I'm all about the lowercase. In fact, just as an aside, whenever you see Merly AI, it's generally supposed to be like this. Like if you see, we're really going off on a rabbit hole here. This is clearly me not racing to the end. I'm trying to avoid getting to the end as much as possible. If you see Merly by itself, it usually would be capital M, but if you see it with the AI, it should always be all lowercase, just for our love of lowercase. Okay, so we're going to do our SSN thing, and let's just, I don't know, what do we want to do here? This is not perfect, but just to make it easy for this prototype, I'm going to just do kind of the lazy way, which is I'm going to call this first, and I'm going to call this second, and I'm going to call this third. Okay, so first of all, I have these private, I'm a firm believer of data encapsulation. I think that this is one of the most powerful concepts of object-oriented programming. I think inheritance generally is not super great. I'm not a big fan, especially if you start doing things like really massive inheritance hierarchies that use things like virtual inheritance. I think it's just really bad. And I've worked with code bases where people have just gone crazy with it, and nobody knows what it's doing. It's not great. So maybe less inheritance, more composition. But I do think that classes are fantastic for data encapsulation and API-driven or interface-driven programming. That part I think they excel in. So I generally try to follow that as like my principle for doing OO. Okay, so let's just quickly. Yeah, you're gonna see some of maybe the wacky stuff that I do here. Okay, I'm gonna actually do this sort of the full wacky way that I would do it. And again, I'm not saying that you should do this, but this is kind of the way that I do some of these things. Why is it trying to format here? Okay, so what I'm doing here is I'm creating a setter, and this setter is also returning what's being set after it sets it, and I like that. but it is returning it as a const ref. Oh, and by the way, the reason why you put the const over here is for things like this template function. It's complicated to explain, but if t is more than a simple type, let's say that it's a pointer, it's an int pointer. When you put const to the left side, what happens is it jumps itself to the next location, which if it's two things, int pointer, it would put itself like this. Right, this is what you'd get, which can be tricky in terms of what you really want. If you really want it to be a constant integer but a changeable pointer, maybe that's what you wanted, but oftentimes people don't realize, I think, that that's what's happening. I think they think that it just moves one over. It moves to the end, but it doesn't. It actually just moves. You're getting this weird camera thing. It jumps essentially all the way to the end. So when you put it on the right side, you know that it's just applying to what's immediately to the left of it. And so and this works just universally. So then if you have something that is an int pointer here, then you do it like this. That's what it's doing. Is it's consting the pointer, not the int. And so you know that this is what it's doing at all times. I might have gotten that first part wrong about when it jumps. I just remember it's like super non-intuitive. And again, these aren't really my rules. This is rules from people that are way smarter than me, that I read a lot and I listen to really smart people. So this is why I do this way. Okay. And RHS is the right-hand side. That's what the shorthand is there. And that's just me being lazy, calling it RHS, because then I don't have to think about it. It's sort of just more mechanical. And then we do third. Okay. Okay, so now what I've done is I've built the scaffolding for this class. It looks like it's compiling okay. Cool. So now I have our setters, and our setters are also getters. But I can also do... I want this to be references. Yeah, it doesn't matter. I can also do this. Just in case we wanted it. And just for the sake of consistency, I'm going to type all this out. Okay, man, Visual Studio is really trying to help me with those minor one spaces. Good job, Visual Studio, you got it. Okay, let's try to compile this again. Okay, that worked. And these guys should be consts because I'm not changing the state. And we want it to not be state changing. And I want these to be const references. Usually these could actually just be const. But I tend to use the references just as a habitual thing in case this thing is like a complex type. Like maybe it's something that's 1 meg in size, and then you forget to pass it or return it by reference, and now you have like this massive copy overhead. So for the sake of consistency, we'll go ahead and we'll make all of these references. This should still compile, I think. Yeah. Now, if I, just as an aside, just to show you, if I drop the const, this shouldn't compile because it should say this is a const. Oh yeah, it's already complaining. This is a const function, and you're returning a reference to a member that is non-mutable, and so that you can't do that. And so yeah, it's like you can't do that, and it's right. I can't do that. I can do this. Okay, so we're getting there, and now. We want to create our constructor, which just Mm. Okay. And 0? 0 seems like a good one. Could be -1. They are ints. I get conflicted about this. Okay. All right, whatever. All right. So now we have our our default values. We're using our member initialization list, and we have the default constructor created. Cool. This compiles. Okay, great. Now, excuse me. The default copy constructor should work for us because it's going to do bitwise copy semantics, which will basically copy all this stuff into the other thing. So we're good with that. But we probably want another constructor that is going to take a first, second, and a third. Yeah. And yeah, we can do the same thing. And so we'll say first is first, second is second, and third is third, and we're good. Okay, is this compiled? This compiles. All right. And the reason for this is now we can initialize the class with just 3 integers, which is what we're probably going to do most of the time. And again, the copy constructor is going to work as we need it to. It probably needs a default constructor for cases where it just creates them as temporaries. The copy constructor will be automatically synthesized. Operator equals will be synthesized. The destructor will have the right behavior. Yeah, I think we're good. Okay, so now I'm going to try to use it for our exclusive and inclusive things, and it's not going to work. And it's going to not work because it's going to say you don't have operator less than and operator is equal to defined, and so you can't do that. But let's demonstrate it first on just the exclusive one, because the exclusive one is only going to use the less than operator. So it'll just say you don't have the less than operator, and then we'll implement the less than operator. Then we'll try to use it for inclusivity, and then it'll say you don't have equals, and then we'll implement is equal. And these are actually pretty easy to implement. So let's say we'll call this test int ranges. And yes, I'm completely OCD about this. I know I have, I'm not right in the head. Okay. And then we'll say, try to compile this. Oh, it doesn't like this because I didn't return a value. Oh. Okay, cool. We'll just whoops. Okay. Do you like that? Okay, it likes this. All right. So those are our int ranges. Now let's do another thing. Let's call this SSN ranges. And this one's not going to work. bool test SSN ranges. And we're going to say SSN, S1, S2. That should work because the default constructor can take no parameters and initialize it. So this should compile. It doesn't. Oh, for different reasons. Okay, cool. Awesome. Now let's see. Does this work? Okay, that compiles. Now, rather than even initialize them, I'm just gonna no, I'm gonna actually do a real one. Okay, so we'll call this lower, and let's just say 0, 0, 0, which is just 0. Yeah, okay, for ones that have leading zeros, it's really just 0. Can we just agree on that? And we can hack it, so if it needs to print out 3 digits and it's like 005, that it'll still print out 3 digits. By the way, I don't know what's up with my camera while it's like flickering like this, but hopefully it's not too bad. I noticed it a little earlier. Hello? Yeah, I don't know what's up with that. Okay, anyway, we'll deal with that later. So this one, we're just going to make this like the most lower it can possibly be. Okay, and then we're going to create the most upper that it can possibly be. By the way, we should do bounds checks on this to make sure that you can't supply greater than this for the first and the third, and it can't be greater than this for the second. We'll add that later. Now in theory, that should compile. Okay, it does. So we have the 2 guys that are just kind of empty. These will be initialized all to zeros. And then we have our super lower bound social security number. Then we have our super upper bound social security number. And now we want to say is within range inclusive. No, exclusive. Yeah. With lower, upper, and S1. Okay. This isn't going to work. It's going to say you don't have the less than operator. That's what I think it should say anyway. Let's see. Yeah. Yeah, it's nope. You don't have this operator. You can't do this. Cool. And we expected that. So it won't build. But we can fix this very easily by just implementing it. So let's just implement the less than operator. So bool operator less than. It's going to take a social security number, SSN, const ref, call this RHS again just because I'm lazy. And then we want to see, is this less than? So how do we define less than? It should probably be a sequential thing. So this is going to be, I'm going to write this the bad way first and then we can refine it. But yeah. Okay, so we'll say, so we're trying to see if this is less than that. Oh yeah, I actually, that's what I do for this, is I call this that. Okay, so we'll say, just to be super explicit, we'll say if this first is less than that first, then then this is less than, right? So basically, in the case where it's like 0, 0, whatever is less than 0, 0, 1, 0, 0, 0. That's just true. This one's always smaller because it's just this first thing, right? So you just check the first number. And if that's true, then this is true. By the way, I can't remember if this is the way the operator less than works. Oh, yeah, and by the way, this needs to be const. So you can call it with const objects. Okay. So that's the first check. And then if that is not true, the next check so there's a couple different ways we could do this. If these numbers are the same, then we have to go to the next number. But a better way to do that, so we go with the bad cases first, is if we say this. We can make this else if, I guess. Kind of doesn't matter. I'm just going to make it if. We can say if that first is less than this first, then this is false. No. So this is basically saying that, back in this case, this is this, who cares, is not less than 0. That's what we're saying here. That's not true. So if this guy, the first, is smaller than this other guy, this is always false. Now we have equality. The only thing that's left in this case is when they're the same value. And so we don't even need to check for that. This goes back to that whole, like, you don't want to embed the scope. So we've returned for the other two cases. The only case that's left is when they're equal. So we don't even need to check for it, because we know that they're equal at this point. So now we can just check on the second one. So we say if, basically the same thing again. This is at the point where I immediately in my head, I'm building an array of these, and I'm calling these, this is just a for, and I have 3 items in the array, first, second, and third. Each iteration through the for loop is accessing the next thing. Man, this camera flickering is like getting wacky on me here. Sorry for that, folks. Just typical live production stuff. But I don't want to do that right now. Maybe offline I'll rewrite it so it does it as an array, and then when we start this on Sunday or whatever and continue, I'll have the new code that just uses them as an array. Okay, so this one now is saying we know the first numbers are the same, and so now this one is going to be like this. These first numbers are the same. This is this, and who cares? This is going to be true. And then that second is less than this second, and this is going to be false. Okay. Perfect. And then, no, we're not going to avoid the copy paste thing. This is going to be 0, 0, 1. Yeah, I would have messed that up if I would have copied it. 0, 0, 0. Okay, so this is false. And now we know the only thing that remains is equality. So it is the case where 0, 0, 0, 0, 0, XXX is this less than 0, 0, 0, 0, 0, Y, Y, Y. Okay. And this is one that's going to throw us a little bit for the loop, because equality is not less than, and we can check for that in the actual comparison. So the first one we check is this third is less than that third, and if it is, then yes, this is less than. Okay, I'm getting lazy. So this, oh wait, yeah. Oh, see, it burned me the moment I got lazy. Okay, and so this one's gonna be Actually, we can just even say that it's this. Yeah. So this one we can say if. Yeah. Yeah. Awesome. We don't actually need to say that at all. We can just say it's not. And the reason why we can say that is if the third one is not less than, then this is not less than. It's either equal to, which is not less than, or it's greater than, which is not less than. So we know the answer. And again, what I love about this is essentially escaping early. So every chance you get, you escape. And notice that we follow the never nester rule here. No never nesting. Okay, let's try to compile. Let's see what happens. Wow, that actually worked. Okay. I actually didn't expect that it would compile, to be honest. Yeah, that's unusual. I thought I'd make more mistakes than that. Okay. So now, okay, this should, come on, Goju. Okay. We're going to do SSN exclusive. Yeah, it's exclusive. Okay. Test. Now, this should be false. It is not exclusive because these guys are being initialized to all zeros, and it's not inclusive, so it should not give us true if we did it right. Okay, so the SSN test should give us 0 if it does the right thing. It did the right thing. Cool. Now we're going to change this so it will give us true. Let's just get rid of this just so we don't have any of this. Okay, so now this should be within the range of lower and upper. And so then when it checks that lower is less than S1, it should be true. And then when it checks if S1 is less than upper, that should be true. Because keep in mind, it's going to do both those checks. Because it's going to invoke this check here. That'll be first. It should be true. And then it's going to check this. And this should be true. And true ended with true should be true. Now, I have a sneaking suspicion we didn't get this right. I think this is not going to give us true. But let's see. Wow. Okay, that worked. This is not a fake wow. I've written enough code to where I'm very shocked when things actually work on the first try like that. And I don't have time to do like a prep thing. So I'm winging it with you guys as we're going along. Okay, cool. So let's just do another test just to see that this actually breaks. Because it should, we tested the lower bound, we tested in between, and now I want to test the upper bound. We really should test all the bounds. We should test the lower bound within one, maybe something in the middle, then within one, then the upper bound. And so you test on both the bounds of the constraints, the lower bound in and out, the upper bound in and out, and then something kind of in the middle. But yeah, this is good enough for our first try. Okay, so this should give us false. If we did this right, this will give us false. Fingers crossed. Okay, cool. That's great. And now, just to make things interesting, this should give us true. Because this is less than this other one. Yeah, this should give us true. I really don't think that we got this right, but okay. Awesome. Okay, we checked this one. Let's just check this last one. This should also give us true. We'll test the first one in a second, the first number. But we already tested the first number with the lower bounds. Okay, so that's true. That's cool. Let's just do it here. Obviously, there's a bunch of tests that we should write. And this should give us true as well. And the reason why I'm like more confident with this one is that we already tested this one for the lower bound. So we saw that it didn't work when these numbers matched, and then it's a one-off because it's essentially inverting the location of the lower, the S1, and then the upper. Yeah, that is strange, the camera flickering. So just to explain what I mean, we're doing each time, and so we tested one where the first number was off by 1 here. So then when we are off by 1 here, I know we've already sort of tested it in this position. So then we're testing it again in this position. And when it worked in this position, it should just naturally, through mathematical transitivity, work for the second position, if that makes sense. Okay. Now, we're not done. There's more that we need to do, but okay. Let's just go for it. Why not? Let's prove to ourselves that this does not work for inclusivity. It's not going to. It's going to tell us that there's no equal operator. Okay. Yeah, I need to learn how to type. That would be the first thing. And now that I know how to type, now it's going to tell us that there's no equal. Okay, cool. But the equal operator is super simple to implement because it's just equality. And that's going to take us 2.3 seconds. Okay, it's going to take a little bit longer than that, but you know what I'm saying. I'm going to follow the madness of Ursmuff, who taught me this little tab thing, just for alignment purposes. I think that he's right about that. I think it just makes it easier to read. Oh, thank you. Visual Studio, come on, guys. Okay, so equality. This is just all this stuff is the same. Told you it was easy. That compiles. That builds. And we are going to just disable this. We're going to show that this doesn't compile because I didn't change it to result 2. Huh? Change it to, is this cap? Uh-oh. Okay. Change this to result 2. And now this is inclusive. Okay, so let's just do a quick test here. This should be true now. If we wrote it right, this should give us a 1, I think. Yep, it should. Okay, it does. Now, this should give us false because this guy is outside of the range. This is actually not equal to this, and so it should fail on this case. And it does. Awesome. And it's okay, buddy. He doesn't like when daddy coughs. I don't know. Do you guys' dog do this? It's something about the coughing. Okay, this should be true. Okay, it is. And then let's test that it's false. Actually, let's Test that it's false in a strange way right here. Okay. This should fail on the second one. And it does. Okay, super. All right. So now I think that we can adjourn for the evening. And we're getting there. We're still not there, because there's some other stuff I want to do. But now we have gone further down the rabbit hole, and what I like is we fixed the range inclusion. We have not yet done the full exhaustive implementation of these things. We've just done implementation of this and implementation of this. 2 and 3 don't exist yet, which is not great. We'll deal with that. But we did fix the -1 and +1, and that was important because we didn't want to implement subtraction and addition, and you can probably tell now why I didn't want to do that, because what does -1 look like for a social security number, right? What does +1 look like for a social security number? That could mean a bunch of different things. Like which number? I mean, you could just add it to the third, but yeah, I don't think so. I mean, I guess in a sense that's sort of what we're doing for equality. Anyway, okay, ignore that. These are not the droids you're looking for. I like it this way because, one, we use the less than operator, and then we do equality. And that's pretty standard C++ stuff. And so now, if you haven't done templates before, now you have a chance at seeing what template functions look like. This is actually a template function that functions like a template. And again, these template functions will work for any class that defines operator less than and operator is equal to. Operator less than just for range exclusion, and less than and is equal to for range inclusion. It's not just our SSN class, it's any class, which is awesome. And I think that that's one of the key powers of templates. And it's part of the reason why I love templates is I get to write really generic code that then just can solve hundreds, maybe thousands of problems. Of course, it's more complicated than that, but I think you can see that when you do this kind of like in an elegant way, even though templates can be very challenging to debug and understand, and we definitely don't want to use them as a flex, I do think that it moves us more toward things like sort of like mathematical purity. Is like the plus addition works for not just integers, right? It works for floating point numbers. One could argue that it kind of could be used for sets and things. I know that sets, it's the intersection. There's no addition operator, but you guys get what I'm saying. Could be used for the addition potentially of vectors and things. Again, I'm sort of mixing metaphors here, so the hardcore theoretical mathematicians are probably swearing up and down right now. But the point is that templates allow us to write very type strict code that also allows us to generalize. And for that reason, I think they're better than void pointers. No offense to the C folks in the crowd. Like, I like C. C's cool, but I really like strict type checking in compilers, because I think having written a reasonable amount of code, if the compiler can detect problems for me at compile time rather than runtime, I'm going to use that superpower. I mean, that's one of the whole points of machine programming. Is machine programming is there to leverage the machine to do a lot of the heavy lifting for you. Allow the machine to handle the minutia. And so I'm just doing the same thing with compilers. Like, compilers are machine programming systems in that regard. So anyway, this was a lot of fun, and we're going through our list, and I just want to go back to our list over here. One, never stop growing. I feel like we grew a little. I did. I definitely am reminded about. I haven't written template code in a while. We are seeking out failure. So we looked for problems in the prior implementation, and we found some and we didn't shy away from it, right? We leaned into it. And I think at the beginning of this, I was saying, I'm going to talk about these, and I'm going to be critical of this, and I'm going to be critical of this. And then I said, don't worry, I'm going to be more critical of my stuff. And I feel like I really leaned into how bad my code is more than these other folks' code. And I think that's really good, right? Let's not shy away from the things that we don't get right. Let's try to really focus on those to make those better. And then small footsteps every day, whether we're tired, angry, happy, whatever, just do it. Just do it. Hopefully we're building stronger and stronger networks with all of you, and Goju Tech Talk we're finding our community. I feel like not focusing solely on the material. I don't know anybody that made any money off of this. I didn't. Merle the dog didn't, and we're just doing this to help the community. We're not getting distracted by the little stuff. I did get a little distracted by the little stuff, but that being the dog. But is he really little stuff? Maybe not. This one in particular, we are focusing on complex problems and iterating. And I think that truthfully, this might be the main point. Is before I was talking about mastering the basics. We're still doing that, right? Because again, I was saying about the template code, you can't really master templates until you master the basics. Like, you can't really even grok the power of all of this until you understand this stuff forwards and backwards. This is the basic stuff. This is the more advanced stuff. And I know many programmers that tried to dive head into template metaprogramming, and it's like, but you don't even understand how classes work. So how can you really leverage this? So don't do that. Don't try to skip to the end. You're not going to become the wizard that is Ur Smuff by jumping to book 12. You have to read the whole series. You have to master all the spells in that book before you can even open up volume 12. And Urs did it the same way. And same with me. Like, we all start with volume 1. Don't read the cliff notes, right? No matter what OpenAI and other people tell you, you can use the code assistance to learn, but don't have that be, I mean, if anything, hopefully this goes to show that you can write code without the machines doing it for you. And in fact, you can also be pretty fast, I think, if you can think critically about problems. It is going to take time, but then think about the freedom that you have when you can do things where you aren't relying on other external factors for all your answers. And again, I'm not saying don't use the AI code assistants. Definitely use them. Just don't be beholden to them, especially for critical thinking. And if you find that you're starting to lose your ability to critically think, maybe go through a detox period for a little bit. And I'm not kidding about that. I mean, really, like, try to program without it. There are cases where you may be in environments where you don't have access to co-pilots or the internet. Like, go work in the classified sector for a decade. No internet. Yeah. So, and I'm not trying to be on a soapbox here. I'm just saying, like, there are reasons to be able to do this stuff on your own, and it can help you. It can help you become better. And Yeah, use the tools when they make sense. But going back to this, like, uh, in order to do the complex stuff, you really need to master the basics. And so we really were mastering the basics. And then this other part about thinking deeply on complex problems, I do think that this is a complex problem. It looks at the surface superficially simple because it's just a range. But then when you try to make it robust, when you try to get it to work for all types, including types that don't yet exist, you have to start reasoning about things at an abstract mathematics perspective. And truthfully, this is one of the reasons why I love C++, is it allows me to reason about objects in terms of pure mathematics, which is part of the reason why I got rid of the -1 and +1 and instead relied just purely on mathematical operators, just the less than operator and just the equality operator. And admittedly, there are first order logic operators in here, the or and the ands, but those have distinct, well, in this context right now, we know what they do, we know what they are. But as we go further, we might look into modifying. I don't know. We'll see. But I think this one on thinking deeply on complex problems, this is also possible because we were not racing to the end. And so I think we are starting to see how we can build these things up together in various ways, and they kind of unlock our potential in different ways. That when taken in isolation, I think any one of these is useful. But when you start to put them together like a jigsaw puzzle, I think they start to really unlock superpowers. So with that, thanks everybody. This was super fun. It's almost 2 a.m. and I think it's bedtime for us.